Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello viewers, subscribers, students, and future engineers. Here is another problem in Vitamath. Call this Vitamath 79, particularly in calculus, and you need advanced skills, advanced training, and experience in calculus in order for you to understand the solution presented in this problem. However, those who want to anticipate the solution to these problems, you may do so by pausing the video. So show that inverse sine of tangent hyperbolic x is equal to inverse tangent of sine hyperbolic x. So we should show that these two are equal. First, let's begin with this expression. Let us denote tangent hyperbolic of x equals sine u. So y equals tangent hyperbolic of x equals sine u, so that u is inverse sine of tangent hyperbolic x, which is this, and we should show that the inverse tangent of sine hyperbolic x is also equal to this. So based on definition on tangent hyperbolic x, it is equal to e to the x minus e to the negative x sine hyperbolic x over cosine hyperbolic x. So this is e to the x minus e to the negative x over e to the x plus e to the negative x. So that's the definition of tangent hyperbolic of x, if you can recall. So simplifying, this is e to the x minus 1 over e to the x over e to the x plus 1 over e to the x. Now, if we simplify this, we have e to the x times e to the x, which is e to the 2x minus 1 over e to the x. So again, this is e to the x times e to the x, so e to the 2x minus 1 over e to the x all over e to the 2x. So e to the 2x minus 1 over e to the x all over e to the 2x plus 1 over e to the x. So we can cancel e to the x, denominator of the numerator, and e to the x, which is the denominator of the denominator. So simplifying, that would be sine u equals e to the 2x minus 1 over e to the 2x plus 1, which is the simplified form of tangent hyperbolic x. So from here, u is inverse sine of e to the 2x minus 1 over e to the 2x plus 1, and we note that this is also the other expression for tangent hyperbolic x. So u is inverse sine of tangent hyperbolic x. So for that part, we should also show that u is equal to inverse tangent of sine hyperbolic of x. So this time, let us denote y equals sine hyperbolic of x equals tangent of u. So that tangent of u is inverse tangent, so that u is inverse tangent of sine hyperbolic x, and sine hyperbolic x is e to the x minus 1/2 of quantity e to the x minus e to the negative x. So that's the definition of sine hyperbolic x. So therefore, if we simplify this, we have 1/2 quantity e to the x minus 1 over e to the x equals tangent of u. So 1/2 of quantity e to the 2x minus 1 over e to the x. So 1 half of e to the 2x minus 1 all over e to the x, and this is the e to the x. So that's tangent of view. Therefore, simplifying further, e to the x, e to the 2x minus 1 over 2 e to the x. So let's define this a triangle showing that sine of u is equal to e to the 2x minus 1 over e to the 2x plus 1. Let's have a right triangle. So from here, u is inverse tangent of e to the 2x minus 1 over 2e to the x. And let's define a triangle, right triangle, from here and show that the definition is the same for both the angles u. So we note that this is the simplified form of sine hyperbolic of x. So we then have a right triangle, and if this is the angle u, then this is, from this definition here, opposite should be e to the 2x minus 1, and the hypotenuse should be e to the 2x plus 1. And let us show that because tangent of u is e to the 2x minus 1, which is this, over adjacent 2e to the x, let us show that this side, adjacent side of this right triangle, is 2e to the x based on this triangle from sine u. So by Pythagoras theorem, this side is square root of the square of this hypotenuse minus the square of this opposite side. So square root of quantity e to the 2x plus 1 square minus quantity e to the 2x minus 1 quantity square. So simplifying, that would be equals e to the 4x, then times 2 plus 2e to the 2x, then plus 1, then minus quantity e to the 4x minus 2e to the 2x plus 1, then e to the 4x will vanish, e to the 4x minus e to the 4x, 1 minus 1 will, so 1 will also vanish. We can only combine 2e to the 2x, and negative of negative 2e to the 2x is positive 2e to the 2x, so therefore this reduces to square root of 4e to the 2x. Square root of 4e to the 2x, of course, is 2e to the x. And therefore, we showed that this side is really 2e to the 2x. So that tangent of u is really e to the 2x minus 1 over e to the x, 2e to the x. So u is equal to u. That means inverse sine of tangent hyperbolic of x equals inverse tangent of sine hyperbolic of x. So we have just shown that tangent of u is opposite, which is e to the 2x minus 1, over this adjacent side, which is 2e to the x. So sine, inverse sine of tangent hyperbolic of x, therefore, is inverse tangent of sine hyperbolic of x. So that's it for this video.